In this video, we are going to talk about double angle identities. So first, let's talk about what those are. So if I'm doing sine of 2 theta, that would simplify to 2 sine of theta cosine of theta. If I'm doing tangent of 2 theta, that would simplify to 2 times tangent of theta over 1 minus tangent squared of theta. Now, cosine of 2 theta has 3 options. The most popular is cosine squared theta minus sine squared theta, but we could also use 1 minus 2 sine squared theta and 2 cosine squared theta minus 1. So in number 1 here, they're telling us that tangent of alpha is negative 5/12 and the secant is greater than 0. So if tangent is negative, but secant or cosine is positive, that means this is happening in quadrant 4. And if I do my opposite over my adjacent, and then this is a 5, 12, 13 triangle. So now they want me to use this triangle to find sine of 2 alpha. Well, that'll be the same as 2 times sine alpha times cosine alpha. So sine would be opposite over hypotenuse. Cosine would be adjacent over hypotenuse. And I can just type that in my calculator, turn it back into a fraction, and I'll get negative 120 over 169. So make sure we give exact answers in the form of fractions, no decimals. Now I'm going to find the tangent of 2 alpha, which is 2 tangent of alpha over 1 minus tangent squared of alpha. So that's going to be 2 times negative 5/12 all over 1 minus negative 5/12 squared. Now be careful, this double negative I can't change to addition because I have to square this part first. So just be very careful. Again, we could always enter this into our calculator. So if I typed in this top in the calculator, I would get negative 5/6. And then if I type this bottom in my calculator, I would get 119 over 144. So if I do the top divided by the bottom, turn it into a fraction, I end up getting negative 120 over 119 as my final answer. All right, now we're going to draw a second triangle, but there's actually a tiny error on this. This should not say 21, it should say 29. So if sine is negative and tangent is positive, that means this is happening in quadrant 3. So if my tangent is, or my sine is negative 20 over 29, this is actually a special triangle, but if we didn't know, it's a 20, 21, 29. But I'm in quadrant 3, so my x is going to be negative 21. Now we have to find sine of 2 theta, cosine of 2 theta, and cosine of 4 theta. So, sorry, it's actually all alpha. Sine of 2 alpha would be 2 sine alpha cosine alpha. So 2 of, well, the sine would be negative 20 over 29, and the cosine would be negative 21 over 29. Again, we can just type that all in our calculator, turn it into a nice fraction, and we're going to get 840 over 841. Now, I'm going to do cosine of 2 alpha. I'm going to have cosine squared of alpha minus sine squared of alpha. We have a couple of choices for this one, but I'm just going to use this one. You could use any of them. So I'm going to have negative 21 over 29 squared minus negative 20 over 29 squared. And again, I can type that in my calculator, turn it into a fraction, and I'll get 41 over 841. Now this last one, they want me to find cosine of 4 alpha. Really, I'm finding cosine of 2 times 2 alpha. And so if I think about what cosine of 2 alpha looks like, that's cosine squared 2 alpha minus sine squared 2 alpha. So just like it was over here, cosine squared alpha minus sine squared alpha, now we're just going to do double. So we're going to do 2 alpha. Well, cosine of 2 alpha, I found out right here, is 41 over 841 squared. And then sine of 2 alpha is 840 over 841 squared. Now, these are not going to type in our calculator and give us a fraction nicely, so I want to think about this as 41 over 841 times 41 over 841. And then 840 over 841 times 840 over 841. So I am going to multiply 41 times 41 to get 1681 over 841 times 841, which is 707, 281. I'm going to do 840 times 840 to get 705, 600 over 707, 281. So I'm going to do 1681 minus 705, 600. I'm going to get negative 703, 919 over 707, 281. All right, so now we're going to go the other way. So now we're going to use our identities to help identify and consolidate. So if I see cosine squared minus sine squared, I know that cosine of 2 theta is cosine squared minus sine squared. So I'm going to go from this back to this. So I'm going to have cosine of 2 times, well, theta is x over 2. So this would simplify to cosine of x. Now number 4 looks a lot like sine of 2 theta because that would be 2 sine theta cosine theta. So now again, my theta is 8x. So this becomes sine of 2 times 8x, which would be sine of 16x. 5 actually is another version of sine of 2 theta. It's 1 minus 2 sine squared of theta. Also is cosine of 2 theta. So now I'm going to have cosine of 2 times 22.5. So that's going to give me the cosine of 45 degrees, which would be root 2 over 2. Now 6 actually looks a lot like sine of 2 theta, but we're missing something. So instead of having a 2 in front, right now I have a 1 in front. So if I think about it, this really should be sine 2 sine pi over 12 cosine pi over 12. So to make that have a 1 in front, it means I multiplied this by 1/2. So really now this is sine of 2 theta, so sine of 2 times pi over 12, still times 1/2. Well, sine of 2 times pi over 12 is going to be sine of pi over 6. Well, sine of pi over 6 is 1/2, so 1/2 times 1/2 is going to give me 1/4. All right, these last two are using some identities. So if I look at number 7, I have a difference of perfect squares. And so this is going to factor into cosine theta minus sine squared theta times cosine squared plus sine squared. So cosine squared plus sine squared equals 1, and cosine squared minus sine squared equals cosine of 2 theta. So 1 times cosine of 2 theta is just going to be cosine of 2 theta. In the second one, I have 1 piece on the left and 2 pieces on the right. So I'm going to start on the right, and I'm going to turn everything in terms of sine and cosine, because right now I have cotangent and cosecant, and I know I have to get back to something with sine. So I'm going to write 2 cosine over sine. Notice I'm just putting the 2 in the top because it's part of the numerator when we have a whole number. I'm not putting it in the top and the bottom. And then 1 over sine squared. So I'm going to have 2 cosine over sine times sine squared over 1. Well, this will simplify with this. So this is 2 cosine sine, which is sine of 2x. That's part of our identities.